Hi, I'm Marty Chance from Neil Chance Racing Converters. Today we want to talk about clutch drag in a Neil Chance lockup converter. We will do a video later that's all about lockup converters and advantages and so on and so forth. Today, just want to talk about clutch drag. Now, a Neil Chance lockup converter, this is what it looks like inside. This is the pump side. This is the Spraggan stator unit. This is the turbine. And this is the drive cover. Now your lockup system is in between the turbine and the drive cover. Now each converter has 6 clutches and 6 steels. They look like this. This is the steel. This is the clutch. Now because there's 6 clutches and there's material on each side of the clutch, that's 12 clutch surfaces. Now the way you stack these clutches in your lockup converter is going to change the drag coefficient. Now, drag coefficient is the amount of power these clutches transfer even when they're not applied. Now, the amount of drag coefficient you want for your application is dependent on the way your motor wants to be loaded. For example, a nitrous motor, say 950 cubic inch nitrous motor, that's a very load dependent motor and wants a lot of drag. So in that case, we would stack all the clutches every other one. This gives us the maximum amount of drag coefficient, like that. That's the way this is set up in here right now. Now, if we was going to do this for, say, an opposite power source, a blown alcohol Hemi, that's a very load-sensitive motor. Now, that motor isn't going to want very much clutch drag at all, so we might stack all the steels together and all the clutches together. And the reason we would do that is when you take these 12 clutch surfaces and stack all of them together, you've turned 12 clutch surfaces into just 2. That's going to give you almost no clutch drag. Let me give you an example. This right here has set up for like the nitrous combination. Lots of clutch drag. See, it's very difficult to spin that. They won't spin independently. Has a lot of clutch drag. Now we lift this unit up. This is the pressure plate, this is the clutch retainer, and this is where the clutches go. This is the piston. Everything's made in-house at Neil Chance Racing Converters on our 5-axis CNCs, all out of billet. We take this clutch system out, which has every other clutch stacked, and if we put in the clutches all stacked together, all the steels stacked together and all the clutches stacked together, we've eliminated all but 2 surfaces. And then we'll demonstrate how that has very little clutch drag and would be used on a very load-sensitive type of motor. Maybe a turbo application that's difficult to spool, or a blown alcohol Hemi, something to that effect. Now this clutch system has so much holding capacity, you don't have to worry about, oh, if I don't have all 12 surfaces, am I going to burn the clutches up? No, I don't care if you got 4,000 horsepower. You're not burning this up. No clutch drag. And that's how you tune your Neil Chance lockup torque converter. Have a great day.